This video will be about the key features of quadratic functions. There are three different forms that we write quadratic functions in. So one of them is called general form. And the A, B, and C would get filled in with numbers to make a specific equation for a quadratic function. A key feature of the graph that we can see from general form is the y-intercept. Intercept is whatever number this C is at the end here. Example, let's say we have f of x equals 2x squared plus 3x plus 7. Our C is 7. So this function would have a y-intercept of 0, 7. Another example. And would have a y-intercept of negative. Form we can use to write quadratic functions is called factored form. To make a real equation. The 1 and 2 are just showing that these are potentially different numbers. They're not the same R. A key feature that we can see in factored form are the x-intercepts of the graph. So those R1 and R2, whatever numbers are being subtracted in the parentheses, are the x-intercepts of the function. So for example, I've got 3 times x minus 2 times x plus 4. Remember, whatever numbers are being subtracted are the x-intercepts. So in here, I see that 2 is being subtracted. So 2 is the x-intercept. Now, this parentheses is a little more tricky because I don't see a minus sign. I only see a plus sign. Well, let's rewrite x plus 4 as x minus negative 4. These are two different ways to write the same thing. Saying x plus 4 is the same thing as saying x minus negative 4. So again, we want to look for what's being subtracted in parentheses. So what's being subtracted here is negative 4. So the other x-intercept is negative 4, 0. The form that we use to write quadratic functions is called vertex form. A, H, and K would be filled in with numbers in an actual equation for a specific quadratic function. In vertex form, we can easily see the vertex. So those numbers H and K are the coordinates of the vertex. The H is the x-coordinate of the vertex, how far left or right the vertex is. And the K is the y-coordinate of the vertex, how far up or down the vertex is. So let's look at an example. Now, similar to factored form, I want to be looking for what number is subtracted in parentheses. And that number is the x-coordinate of my vertex. So I know my vertex is going to have an x and a y coordinate. The x-coordinate is whatever is being subtracted in parentheses 2 is being subtracted in parentheses, so 2 is the x-coordinate of the vertex. And then whatever number is being added on the outside is the y-coordinate of the vertex. 4 is being added on the outside, so 4 is the y-coordinate. So our vertex is going to have an x and a y. Keep in mind the x-coordinate is what's being subtracted from x. Well, I don't see any subtraction here. So let's rewrite that as subtraction. X plus 7 is the same thing as x minus negative 7. So negative 7 is what's being subtracted from x. Negative 7 is the x-coordinate of the vertex. The y-coordinate is whatever is being added on the outside. I don't see a plus, I only see minus 18. But subtracting 18 is the same thing as adding negative 18. So what's being added on the outside is negative 18. So negative 18 is the y-coordinate of the vertex. So we just looked at 3 forms of quadratic equations: general form, factored form, and vertex form. The one piece that all the forms share that we haven't talked about yet is this a in the front. So a controls how wide or narrow the graph is, but the most important thing to know about a is that the sign of a controls whether the graph opens up or down. So if a is a positive number, a number greater than 0, if a is a negative, if a is a number less than 0, then the graph will open down like a rainbow. So for example, if I have a function f of x equals negative 3x squared plus 2x plus, just by looking at that negative 3, I can tell that this function is going to open down like a rainbow. But if the function had a positive 3 here, then that would mean that the graph opens up like a U. Let's see how we can use these forms of equations to match up equations and graphs. So here we have a graph of a quadratic function, and we have 3 equations, one written in factored form, general form, and vertex form. So let's use what we know about the key features in each form to decide if these equations could go with that graph, if they could model that function. So let's start by looking at our factored form equation. First off, we can see that the a value in front is negative, so this graph will open down. So that's a good sign. In factor form, we can see the x-intercepts, and remember the x-intercepts are the numbers that are being subtracted in parentheses. So really, we can think of this as x minus negative 1 and x minus negative 4. So f of x will have x-intercepts of negative 1, 0, and negative 4, 0. Does that line up with this graph? Let's see. This graph seems to have 2 negative x-intercepts, and it opens down. So yeah, f of x could be the equation of this graph. Let's look at g of x, our general form equation. First off, we've got a negative a value in the front, so that's a good sign. This graph is going to open down. In general form, we can see our y-intercept, and it is whatever our last number is on the end here. So this function will have a y-intercept of 0 and negative 6. Let's see if that could be true of this graph. So we can't see the y-intercept on this graph, but we can assume that the graph will keep going down forever, and eventually it will hit the y-axis somewhere down here, somewhere in the negatives. So yes, because this graph opens down and has a y-intercept that is negative, g of x could be the equation that models this graph. Lastly, we're going to look at h of x, our vertex form equation. This also has a negative a value in the front. It's a negative 1. So h of x definitely opens down. And in vertex form, we can see the vertex. Remember, the x-coordinate of the vertex is whatever is being subtracted in parentheses. So 6 is being subtracted in parentheses. And the y-coordinate is whatever is being added at the end. So 3 is being added at the end. Let's see if this graph could have a vertex of 6, 3. Here's our vertex. Well, this vertex has a negative x value, whereas h of x has a vertex with a positive x value. So no, h of x could not model this graph. Even though h of x and the graph both open down, h of x is going to have a vertex with a positive x value, while this graph has a vertex with a negative x value. So that's an example of how we can see key features of quadratic functions from equations and compare them to graphs.